Hey there, Math Wonders. In this lesson, you will learn how to identify linear functions and linear equations and to graph linear functions. Alright, so this graph represents a function because each domain value, the x values, is paired with exactly one range value, the y values. Notice that the graph is a straight line. A function whose graph forms a straight line is called a linear function. Makes sense? So we're going to identify whether this graph represents a function, and then you need to explain it. So if the graph does not represent a function, if it does represent a function, tell me if the function is linear. So we see here that every x value has exactly one y value, and we know that by using the vertical line test. So it appears to be a function, and that function creates a straight line, so this does indeed appear to be a linear function. Let's check this one out. Let's see, does every x value correspond with exactly one y value? Sure appears so. Every value in the domain has exactly one value in the range. But it's not a line, so it's not a linear function. What about this one? Every x value does not have exactly one y value. Here, 2 in the domain, it has a pairing of 1, 2, 3, and all numbers greater than, as well as -1, -2, and all numbers less than. In addition, all those little fractions and decimals in between. So this is certainly not a function. So it's certainly not a linear function. Alright, now you guys try this, please. Tell us whether it's a function or not, and if it is, tell me if it's a linear function. Pause your video now. Alright, welcome back. Hopefully you identified that the domain has exactly one value in the range, and which makes it a function. And as a function, it creates a line, thus this is a linear function. Try this one. Pause your video now. Okay, so we have another line, and it's a horizontal line, but does each x value have exactly one y value? Let's see, 1 is paired with 4, 2 is paired with 4, 3 is paired with 4, 4 is paired with 4. They're all paired with 4. Is that okay? If you don't remember, we can look at the vertical line test, which this appears to pass because the line does not intersect more than one point on the line. So this is a function. It is a straight line, thus it's a linear function. Let's try one more. Pause your video. Well, obviously this is not a line, but is it a function? Does every x value have exactly one y value? I would suspect this right here. When x is 1, it appears to have a y value of 1 and a y value of -1. So no, this is not a function. Each domain value is not paired with exactly one range value, and it's certainly not a linear function. So sometimes you can identify a linear function by just looking at a table or a list of ordered pairs. In a linear function, a constant change in x corresponds to a constant change in y. That does not mean the same change that's happening in x values is the same change that's happening in y values. It just means that the constant change in x corresponds to a constant change in y. So let's take a look at what that means. So in this case, this table of a linear function, the x values are increasing by 1 each time. Now, as each x value is increasing by 1, the y values are decreasing by 3. So because they have that constant change in x values and the constant change in y values, that makes this a linear function. If we were to graph it, they would form a line, as you can see here. Each x value is assigned exactly one y value. Okay, looking further, the constant change of plus 1 in x does not correspond to a constant change in y. Here we've got minus 3, minus 1, plus 1, plus 3. So this would not give us a linear function. It has to have that constant change. And they would not form a line, as you can see. So tell whether the set of ordered pairs satisfies a linear function, and then explain. So given a table and a set of ordered pairs, I'm going to put those ordered pairs in a table to help me see the pattern. It appears that I'm adding 4 to each side on the x values, and I'm adding 3 to each side on the y values. So because we have that constant change in x's and corresponds to the constant change in y's, we indeed have a linear function. Okay, now you guys try. Tell whether the set of ordered pairs satisfies a linear function. Pause your video now. Okay, so when you place your numbers, your ordered pairs, into the table, so we can see in a pattern, I see a pattern of plus 2 on the x values, but not a consistent pattern on the y values. Minus 12, minus 4, plus 12. So this is certainly not a linear function. A constant change of 2 in x corresponds to different changes in y. This is not a linear function. Let's try one more. Pause your video. Once again, we're going to place our ordered pairs in the table so that we can see the pattern that's occurring between the x values, which appears to be plus 2 each time, and y values appears to be minus 1. So because we have that constant change in x's that's corresponding to the constant change in y's, we've got a line. This is a linear function. Okay, so another way to determine whether a function is linear is to look at its equation. A function is linear if it is described by a linear equation. A linear equation is an equation that can be written in the standard form shown below. The standard form, is ax plus by equals c, where a, b, and c are real numbers and a and b are not both 0. If a and b were both 0, then this would simply be 0 equals some constant number. So the coefficients in front of x have to be real numbers, and they both cannot be 0. So let's take a look at what that means. So we're going to work on identifying whether or not an equation is linear just by its look. So notice that when a linear equation is written in standard form, both x and y have exponents of 1. X and y are not multiplied together. If that's the case, it's not a linear function. And x and y do not appear in denominators, exponents, or radical signs. Those graphs would not create lines if it appears in the denominator, exponents, or radical signs. So that would be good to know. So let's take a look at an example. Standard form of a linear equation, 3x plus 2y equals 10, ax plus by equals c. Here's another one. This could be rewritten when we get to the variables on both sides as 3x minus y equals negative 2. So this is the standard form. And even this one, you don't see an x value, but we can imply that there is, we don't see a constant value, but we could still get both variables on the same side and set it equal to 0. So these two equations are equivalent. So that's a line as well. That's in standard form. Unlike the nonlinear equations over here, where we've got x and y being multiplied together. That's not linear. We've got x raised to the third power. Remember, if it's linear, all the exponents are 1. And then here, the denominator is in, the y is in the denominator. That can't be the case. So for any 2 points, there's exactly one line that contains them both. This means you need only 2 ordered pairs to graph a line. So even though 2 ordered pairs is enough to graph a line, sometimes we like to have 3 just to be sure. So tell whether the function is linear. If so, graph the function. So what I'm going to ask myself is, can I rewrite this such that the x and y are on the same side together? If so, then I can probably write this in standard form. So in order to get x and y both together, I subtracted 2y from both sides of the equation and gave me x minus 2y equals 4. ax plus by equals c. So if this can be written in standard form, then this is a linear equation. Notice that the coefficients, we have coefficient 1 is a, negative 2 is b, and then 4 is c. Okay. To graph this, we could choose 3 values of y. Since x is already isolated, it makes sense to pick values of y for our table in this case. Now, we only need 2, but we're going to do 3 just to make sure. So if I put 0 in for y, I get a x of 4. Y negative 1, x is 2, and if y is negative 2, x is 0. So if I were to graph those points, I do indeed get a straight line. So you guys try this. Tell whether the function is linear, and if it is, graph the function. Pause your video now. Alright, welcome back. Hopefully you recognize that this is not in standard form, nor can we write it in standard form. We can't split those x and y values up with addition. So because they're being multiplied, this is not standard form because x and y are being multiplied. Okay, what about this one? Tell whether this function is linear. Alright, hopefully you will attempt to get x and y both on the same side. And we can do that by subtracting 5x from both sides, giving us negative 5x plus y equals negative 9, which would be in standard form with a value of negative 5, a b value of 1, and a c value of negative 9. So because this can be written in standard form, the function is linear. And let's do one more. I'm sorry, we're going to try to graph this now. So now in this case, y is already isolated, so we're going to sub in values for x. And I just kept it simple, 0, 1, 2. Sometimes I like to get some negatives in there, but we want to keep the numbers small and simple so the computation's easy. And this does indeed give us a linear function. And let's try one more. To tell whether the function is linear, y equals 12. Can we rewrite that in standard form? Well, you might not think so, but if you recall that if there is no x, we could always make a coefficient of 0x. So this is written in standard form. This could be 0x plus 1y equals 12. So if it's as it is a linear function. What would it look like? Well, if we were to graph it, y equals 12, that means all the points that have a y value of 12. So it'll be a horizontal line going through the y-axis at 12. And one more time. Y equals 2 to the x power. If you look back in your notes, you see that x or y cannot be exponents. This would not make a line. So this would not be a linear function. No need to. In this lesson, you learn how to identify linear functions and linear equations, and to graph linear functions.